In this module, linking probability to statistical inference, we work with categorical variables. So they're not going to be variables that are numbers. They're going to be variables that are categories or words, I guess. So the statistics and parameters will be proportions. In the module that we'll see in the future, inference for means, we work with quantitative variables. So a variable that is a number. So the statistics and parameters will be means. In the big picture, we see that inference is based on probability. In this module, we begin the process of developing a probability model to describe the long-run behavior of proportions from random samples. After we develop a probability model of how sample proportions behave, we can answer questions like the following. Do the majority of college students qualify for federal student loans? Or what proportion of all college students in the United States are enrolled at a community college? The questions above ask us to make an inference about a population. Our answers to these questions will be based on a sample. We will never be 100% sure of our answer, so we will make probability statements that describe the strength of the evidence of our certainty. We'll never say, with 100% certainty, blah, blah, blah. We'll always say, with 90% certainty or some percent certainty below 100. Now we'll do a brief discussion of the connection between these questions and probability. The first one we asked, do the majority of college students qualify for federal student loans? This question is asked to test a claim about college students. This claim is the majority of college students qualify for federal student loans. To test the claim, suppose that we select a large random sample of college students and find that 40% of the sample qualify for these loans. A majority requires over 50%, so 40% is definitely not a majority. Can we conclude from this sample that our claim is incorrect? Or could this sample have come from a population, the majority of which qualify for loans? What is the probability that sample proportions will be 40% or less if the majority of the population qualify? So it sounds kind of similar to the one we saw on the previous page about that court case. What are the chances that student C got 13 of the 16 wrong answers, the same as someone else? Kind of like that. What proportion of all college students in the United States are enrolled at a community college was our second question. Well, this question asks us to estimate a population proportion. Suppose that we select a large random sample of college students and find that 46% are enrolled at a community college. What is the probability that an estimate from a sample is within 3% of the population proportion? That's what we'd like to know. Okay, I'm going to move down, let's see. Okay. Now note, connected to each inference question about a population proportion, we see a probability question about the long-run behavior of sample proportions. We need to understand how proportions from random samples relate to the population proportion. We also need to understand how much variability we can expect in sample proportions. Therefore, in our early investigations, we will assume that we know a population proportion and examine what happens when we select random samples from this population. Now we'll begin our investigation of the long-run behavior of sample proportions. Here's an example to illustrate. It's about gender in the population of part-time college students. According to a 2010 report from the American Council on Education, females make up 57% of the US college population. With the rising costs of education and a poor economy, many students are working more and attending college part-time. We anticipate that if we look at the population of part-time college students, a larger percentage will be female. Let's say that we predict that 60% of part-time college students are female. We don't have information about the population of part-time college students, so we select a random sample of 25 part-time college students and calculate the proportion of the sample that is female. We don't expect the sample proportion to be exactly 0.60 or 60%. So how much could the sample proportion vary from 0.60 for us to feel confident in our prediction? To answer this question, we need to understand how much sample proportions will vary if the parameter is 0.60.